It is a Typhoon Class Nuclear Powered Submarine whose weight is 48,000 tons, and there is a huge ship on the side with a load carrying capacity of 240,000 tons. It is a matter to think that such a heavy ship floats comfortably on the water, and the submarine can easily go into the water while it is one-fifth in weight. When any body is in water, the water exerts an upward force on that body, which is called buoyant force, and the gravitational force tries to pull that body down, and both these forces are available in the water. Using buoyant force, Archimedes gave a principle that when a body is immersed in water, that body will start displacing water. Now, the weight of the water displaced by this body will be equal to the buoyant force exerted on it. It is very good, but still we do not understand anything. The weight of this submarine of ours is 48,000 tons. When it stays above the water, it is assumed that it can displace only 40,000 tons of water. Now it will be equal to 40,000 ton buoyant force, which means 40,000 ton water is exerting upward force on this submarine. But I just told that there is also a gravitational force whose formula is mass times gravitational constant. Write the value of gravitational constant in comment. Now, if the gravitational force exceeds the buoyant force, the submarine will sink. So the simple thing to do is when the submarine is about to go into the water, then to increase the gravitational force, it will start increasing its weight. And to increase the weight, there are tanks which remain on the bottom side of the submarine, in which it will start filling with water, and as soon as the gravitational force is high, the submarine will start going down. The large ships displace a lot of water so that the gravitational force does not dominate and the ship moves comfortably on the water. The Typhoon class submarine is still with Russia, whose power we are yet to know. Nuclear weapons can also be launched from this submarine, and it simultaneously carries so many weapons that the whole Earth can be destroyed. This submarine is 574 feet long, 76 feet wide, and 38 feet tall. If it is compared to a human, it will be something like this. Living facility is available for 160 people in this submarine, and it can stay underwater for 120 days without coming out, whereas those who are diesel-electric submarines have to come up once in 10 to 15 days because the diesel engine emits a lot of exhaust, due to which bubbles are created in the water and its privacy is lost. That's why the diesel submarine charges the battery on the surface and then goes back into the water. The outer body of the submarine you are seeing is called hull, but inside it there are total 5 hulls. There are 2 large main pressure hulls on the side, which are made of strong steel, and each hull is divided into 10 compartments, and in these compartments sleeping room, kitchen, bathroom, gym facilities are available for crew members. On the rear side there is engine room that has the nuclear reactor for power generation and propulsion of the submarine. The submarine has a torpedo hull at the front from where the missile ammunition is launched. The torpedo compartment does automatic launching, just needs to be signaled from the control room. And the control unit of the submarine is in its center portion from where the crew members work. Submarine driving control. Submarine is going down in the water, going up, servicing, etc. All are controlled from here. But the interesting thing is that there is no window to see outside the submarine. Everything is controlled through sensors from its control room. Submarine is just like a box, which makes minimum movement with water. Inside things inside, outside things outside, so electrolyzer is installed to supply oxygen to so many crew members. Electrolysis is a process in which oxygen is extracted from water. If you know, oceans supply 50% oxygen on Earth, so oxygen is much available inside water, but electrolysis is used to separate it from water. There are 2 graphite rods in different chambers. When DC supply is given to them, oxygen will be released from the positive electrode side, and hydrogen will be released from the negative electrode side. Both these gases are stored in separate tanks. Oxygen is supplied to the entire submarine through these pipes, and hydrogen is released outside. The submarine has a powerful electrolyzer that produces 4,000 liters of oxygen in 1 hour, yet oxygen is supplied periodically. There may be a power failure and this system may not work, so for backup, chlorate candles are used for oxygen supply, which do not require any external power source. These candles are sealed in a steel canister. Ironuder is filled in the middle of the candle, and sodium chloration the side. So when oxygen is needed in emergency conditions, iron powder is ignited, which generates heat. And the chemical reaction starts at 600 degrees Celsius, and oxygen is released in tremendous amounts. In a nuclear powered submarine, a nuclear reactor is used for power generation and to propel the submarine, in which uranium 235 is used as a fuel. This reactor can generate continuous power even underwater because, like a diesel engine, it does not leave any exhaust outside. If we compare it with the diesel electric submarine, then 5 million liters of diesel is equivalent to 4 kilograms of uranium. And the more interesting thing is that there is no need to come out to refuel nuclear powered submarine because when the submarine is manufactured, at the same time, so much uranium is filled in it so that it does not have to do any refueling for the next 30 years because uranium is not like diesel petrol, which gets refilled often. Now, friends, before knowing about the reactor, let's promote our course a little. Now, it is true that the tremendous time of 3D animation is going on. If you also want to take advantage of this time, then you are most welcome in our 3D community. You will have full support from our side. The website link is available in the description. Now, coming back to the topic, there are two pressurized water reactors in the submarine, in which there are many such tubes. Inside these tubes, small pellets of uranium are set in such a way that they are sealed in a metal tube, and many of these tubes make a whole bundle of fuel, and in the reactor, they are set in this way. When the reactor has to be started, the process of nuclear fission is started here. When a neutron is added to a uranium atom, it breaks into two uranium atoms, and neutrons are released from this break, and energy is also released. Now, both these neutrons will attack the next atom, due to which the next atom will break again, and energy will also come out, and neutrons will also come out. In this way, a chain reaction takes place here. Set a uranium atom on fire, it will break the next atom and release tremendous energy, but this chain reaction is controlled in this reactor because if the uranium atom continues to move in this manner, then this reactor turns into a nuclear bomb. Leave aside the reactor, it can wreak havoc in the entire ocean. Therefore, this chain reaction is controlled by a rod of cadmium or graphite, and these rods absorb the extra electrons and slow down the reaction a bit. Here, the water is filled around the metal tubes. Then, when energy is released from the fission process, the water is heated by it and the water is sent forward to the steam generator. There are many shaped tubes in the steam generator through which this heated water flows, and there is another source of water inside the steam generator, so when this water comes in contact with the reactor water, it will get heated and turn into steam. There are three steam generators with a reactor, and steam is sent from these steam generators to the turbines, which rotate the turbines. Now, the power of the turbine is not given directly to the propeller because the turbines rotate at a very high speed, so a powerful gearbox is used to control their speed, the power of these gearboxes to the propellers that propel the submarine forward. You know, uranium is a radioactive material, so it can cause a lot of harm with its radioactivity, so the reactor is packed completely. Nuclear submarines carry many weapons. This submarine can also launch missiles, and the missile system is between the two main pressurized hulls of the submarine. But it is a matter to think that the rocket engine needs air to burn, so it cannot run in water. Then, how is the missile launched from the submarine? When the missile has to be launched, its cap is open and there is a launch tube under this cap. The launch tube is also packed tightly so that water does not go into it. Compressor tanks are used to launch these missiles, so when the rocket is to be launched, the compressor tanks will start compressing the air under the launch tube. When the pressure increases, the seal will break from above, and this air pressure tank exerts so much pressure on this missile that the missile will be launched from the sea at 80 kilometers per hour speed. This pressure is so sufficient that the missile reaches the surface, and as soon as it reaches the surface, its fuel will ignite and start moving towards its target. A submarine can go 400 to 500 meters or up to 800 meters. In the depth of more water, the ocean puts a lot of pressure on the submarine, due to which such a big body gets squeezed like a box, so the submersible is used to go into more depth. Power generation continues in nuclear power submarines, and unlike diesel electric submarines, they do not have to carry extra batteries and fuel, due to which their power has increased a lot, but their cost is 2 to 3 times more than diesel electric. We talked about many facts related to submarines in this video, so do watch this video once. Subscribe to my channel also because we need your support a lot for our survival. Thank you.